Okay, so we're going to quickly review net ionic equations. We want to start with the balanced chemical equation, which is also called the molecular equation. And it's called the molecular equation because everything is written as molecules or whole compounds. Nothing's broken up yet. You want to make sure that you include the states for each substance. Our next step is going to be breaking up all the appropriate substances into ions. You're only going to break up ionic compounds that are aqueous or strong acids dissolved in water. If you remember from last year, when ionic compounds dissolve in water, the ions separate from each other and are surrounded by water molecules. So a soluble ionic compound, once it's in water, it exists as separate ions, not as the whole ionic compound together. Similar case for strong acids. Strong acids break up completely, which is why we express them as the separate ions. You never break up solids or liquids or weak acids. Even though weak acids also dissolve in water, they exist primarily in the form of the molecule, and so that is how they are represented. Here I have a strong acid and two aqueous ionic compounds, lithium hydroxide and lithium sulfate. I will break up all three of those substances. I will not break up the water because it has an L sign, it's a liquid. It's also a molecule, and we don't break up molecules. Okay, note that I include the charges and the states on all the separated ions. So, this whole thing is the complete ionic equation or ionic equation. Now we're going to go ahead and create the net ionic equation. And the next step in doing that is to cross out all the spectator ions. You can only cross out like numbers. For instance, I have 2 lithiums on the reactant side and 2 lithium ions on the product side, and therefore I can cross them out. The other thing I want to mention now is you can only cross out substances that are completely identical. So, for instance, if I had copper 2+ on the reactant side and copper 1+ on the product side, I could not cross them out. So, I'm going to go ahead and cross out the spectator ions now. And as a final step, I will go ahead and rewrite the net ionic equation so it is neater. And here it is. I will point out one last thing. If you notice, there were 2 H+, 2 hydroxides, 2 waters, and I reduced it so there is 1 of each of those substances because we want to reduce our coefficients to the smallest number possible.